Hi everybody, let's see if we can build a military jump pack for starting military equipment like this generator out of headway cells. Here we go. So I've got the covers off of this big Super Beast battery. You can see we've got some bus bars here, big headway cells. Now this is a power pack. It's really made for high discharge current, but it's not a whole lot of capacity stored into this package. I think we have like 1.3 kilowatt hours, but it's a really nice package. So up here we've got our constant negative, and then we've got our positive coming up, fuse, current transformer, and then over here this is constant positive power, and then this one is the relay, the contactor here is controlling this output. So this one's currently dead. It would need power. This is the end of that. So there's no power being delivered to the relay currently. So some of the wires in this bundle we don't need. They're going to be for the current transformer, for the fan, and we don't need those. And there's also some temperature sensors throughout this battery pack. But I'm going to try to make this whole thing operate with this inexpensive little BMS that I got from Battery Hookup. And so it says 30 amps on it. All we're going to try to do is run this relay with this BMS. So I'm going to be having one side of the wire here attached and the other side go up onto the main negative. So right now I need to identify the 9 wires that are connected to the cell groups. So the 9 voltage sense wires. And I don't need the wires for the current transformer or the fan. This battery pack from Battery Hookup is comprised of 8 cell groups in series to create the 24 volts. Each cell group has 6 headway cells in parallel. I'm checking the voltage of each cell group to make sure that I don't have any like self-discharging cell groups or something that's really out of whack. I want them all pretty close to each other, and they are, which is very nice to see. I plan on using this battery pack to jumpstart diesel engines. Now that will require a huge amount of power, a very large inrush. So that inrush could be over 1,000 amps for a very short period of time in order to get that engine turned over. If I tried to do that with a BMS that ran all the current through MOSFETs, I would likely blow out all the MOSFETs. And if there was a BMS that was MOSFET based that could handle it, it would be extremely expensive. In this case, I'm using a very inexpensive $10 BMS to drive a relay that's already built in. Now this contactor that's built into this pack is rated for 500 amps continuous, and for very short durations it can do 1700 amps. So the contactor is definitely not going to be the weak link in this jump pack, but I still need to make sure I don't overcharge or over discharge any of the cell groups, and that's where the BMS comes in. Overall, this should work out pretty well, but I've never done it before, so let's find out how well it works together. So that was actually really good. We just had one cell group that was a couple of tenths lower. It was a couple hundredths lower, 3.23, I think it was. But that means we're all really balanced. And this is straight from Battery Hookup. I haven't done any balancing or anything with it. So now what we'll do is put our lead on the main positive here. And again, on the main positive to the main negative, we're looking for 26.2. So we're going to try to find which one of these is 26.2. There we go, 26.2. So this one is the one that we need. So we're going to want to cut this wire. It's going to be our main negative. And this is the wiring harness that came with the BMS. So we're going to take our main negative wire for that, and I like to cut off the little soldered tip on there. Now this is going to be pretty thin. And then this one seems to be a thicker wire. This little BMS came with this wiring harness, and on this wiring harness we've got a red for the main positive and a black for the main negative. We can verify that by looking closely at the circuit board. Let's see if it'll zoom in here. And you can see battery 0 or 1, 2, etc. So when we plug this into the wiring harness, it goes in like that. And this black wire is for the 0. Goes over here on the 0. And so that's how we know that this is the main negative. Now I also want the ability to read what the voltages are because this doesn't have a Bluetooth or something built in. This is a relatively inexpensive BMS. So if I want to use a little gauge like this is a little ISDT BAT-GO, or if I want to use something like this guy, an iCharger, something like this, I can balance the cell groups out. Then I need a different JST connector. So this is JST-X8. It's a 9-pin connector. And when you plug this in, when you plug this in, there's little, let's see if it'll show up here. You see the main negative is all the way to the left. And when you plug this in, the left wire is actually red. So if I wanted to, I could press these pins out and swap them. This should be the main positive over here, and this one's the main negative. But I don't care enough to actually press those pins out and swap them, so I'm just going to solder this on knowing that it's the main negative. We basically have 3 wires here that we want to connect up. So we've got these 2 wires here. Then I'm going to take this little, this is a little heat shrink. It's got some adhesive and some low temperature melt solder inside there. So now we've got all 3 wires coming together inside this. All right, now we have our very last wire. Now our last wire is going to be over here, and as you can see it's 0 volts, so that's not going to work for us. We need to be able to measure it. A lot of these are going to be 0 volts, the ones off the fan and the current transformer. So I'm going to move the red probe, or you know, it doesn't matter. You can just move whichever one you want. But now 26.2 is what we're looking for our final positive wire. And I'm just going to prep these 2. And over here, prep this one. And now we're looking for our final one, which is going to be over here on this side, 26.2. And that's this little blue wire up here. Let's see if you can zoom in a little bit on that. So right here, this blue wire. So I know I'm looking for a blue wire out of the bunch. And it looks like we have 3 blue wires. So it's one of the 3. 26.2. So that's our winner. I'll fish this wire out of the bundle. I want to bring it around to the opposite side. Verify it once again, 26.2. And now we'll bring this wire up and around. I'm making sure I'm not twisting it up with my voltage voltmeter wires. All right, well that's all of our wires. Now I'm just going to do a little bit of dressing up, make them a little bit neater. When I dress up these wires, I like to use this Tessa tape. And this was a suggestion from a viewer years ago, and I'm so grateful for that because it works awesome. Rips easy and does not leave sticky residue behind. So for this particular one, I'm going to dress these down. Like this, and we're just going to group these all together. So we've got our JST connector just for checking the voltages whenever we feel like it. We've got our BMS connection. The rest of these we don't really need. So I'd like to be able to say that I could just go and snip all the wires like that. However, if I made a mistake and some of these wires are connected to one of the voltage things, I could have some sparks. So I don't want to risk that. So instead, what I'll do is I'll cut them one at a time, and I'm going to stagger where I cut them by about 1/2 inch. There we are. So now I don't need this harness anymore. Well, let's fix this up. And then I'm going to go a little bit step further, and I'm going to wrap some Tessa tape around this. All looks good. Now this is where I had wrapped this up with some electrical tape. I'm going to take that off now. This has been charging for a couple of hours. Let's see how we're doing. Well, great. As you can see, cell number 3 has reached the high point of 3.65 volts and is currently balancing. The little graphs next to them, the little bars next to them, shows how much they're balancing. So that's great. It has dropped the current down, so still needs to keep going. But cell number 3 is our, or cell group number 3 is our high voltage cell. Well, we've entered the constant voltage mode, and as you can see, the amperage is going way down. It's almost done. We're only 1 millivolt delta at the top end here, so we are really well balanced up here at the top end. And this is about to beep and be all done, totally balanced. And now we're all done. Excellent. It says 4 millivolts. On top here are some M5 by 0.8 threads, and that's kind of an oddball size. So I went into my bag of nuts and bolts here, and these I actually took out from a BMW battery that I took apart a couple years ago, and found some that worked. They were just a little bit too long, but I cut them down and then chased the threads, and now they should work. So I'm going to put the positive wire here in the constant on. This is an always on positive bus bar. This is the bus bar that's switched. And I found these these bolts here, or these machine screws. These are also from the BMW battery. Okay. And now this negative side, we can do the same thing. And really, I should probably have some washers or something in here. So let's see what we've got here. We've got a 30 amp BMS, 10 gauge wire. This is the negative side. Then it comes out of there and we've split it. And so I've got negative going to the switch. That'll just simply light up the little light. And the other side of it goes to the relay. The relay is our only load. The relay maxes out at 3 amps, but only when it's closing. And then it draws almost nothing after that. I put a 10 amp fuse in here, and that is powering the switch and then powering the load, the relay. If we wanted to get even more fancy with this, down here, this is a 24 volt heater, which is sitting down in the bottom. That's that silicone pad. We also have a 24 volt fan here. So we could run both of those items if we wanted to, and the 30 amp BMS would still have plenty of power for all of that. we would just need some more switches. Let's give it a shot. Let's see if this works. So from our positive side, which will be over here, to our negative, you can see we got 0 volts. And now if we turn it on, 27.8 volts. All right, so that does work. Turn it off. Zero. 27.8. Wow. That's fantastic. It does work. Oh, let's check the amperage that this draws. DC amps. Says right now we're at 0.26. Can you see that? 0.36. So a tenth of an amp. That's not much at all. Listen for the relay. Oh, that's cool. All right, so next step, I've actually got to make a couple of leads coming off here because I have a use for this. So let's get to using it. Well, this 24-volt battery is capable of a ton of amps for a short period of time. And that's one of the reasons that I used the relay that's built into this pack. I really want to be able to discharge a lot of energy. So I'm going to actually make a jump pack for military equipment. Military equipment runs on 24 volts. And military equipment uses a NATO plug. This is the NATO plug. And so what I'm going to do is remove the back and run some wires in, and we'll get this hooked up and see if this can be a jump pack for military equipment. Let's try it out. Inside, labels out our positive and negative. It's printed right there. We'll just take those bolts off. I got some of the old military jump cables, which when we were in, we used to refer to as slave cables. And I cut it out. And I've made these cables a long time ago, and I just use them over and over on different projects. The wire inside is 1/0, but it's got a massive insulation around it. So it looks more like a 2/0 or something. This plug came with what they call bushings. These are made out of aluminum, and they're sized for 4 gauge. But I'm using the thicker wire instead of the 4 gauge. 4 gauge probably would be fine for my application, but you know, I just wanted to, maybe I'll get the opportunity to try to jump like a 5-ton or something in the future, and that'd be fun. All right, so now that that's lined up, let's get one of these bolts in there. So I'm putting some more tape on here. I already have some heat shrink. I don't need more tape, but I'm just making this a little bit wider so that it's a tight fit on the aluminum. There you go. See, I got to kind of work it in there. It's a little snug, which is what I want. Get the last one on here. These are tight. Throw this back on. Good. All right, we got our end on there. Now the other end is going to come up here. Well, we got our plug. Got all our stuff set up. That turns it on. Turns it off. So it's definitely not neat and tidy like some of my builds I try to do, but this one I'm really just trying to proof of concept. I've never done the BMS controlling a relay before, and I thought this was a perfect application. So next is to try to jump a piece of military equipment. So here's the NATO plug, and it goes all the way back. Now, Eleanor, can you press this blue button for me? Yay! So, Eleanor, pull the switch back out. Good. All right, so next what we're gonna do is we're gonna check. We checked that. Look at all the red lights. Go ahead and press that. Good job. Let go. All right, and we have a little bit of fuel, not much. The sound that we hear is the pump priming the fuel system. That only has to go a few seconds. And now we're gonna start it up. All right. It worked! It did it! The jump pack actually turned it on. Now we got 240 volts, okay? So what we're gonna do is we're gonna close the circuit, press that up. Good, let go. Now we got our light on. Good job. And we got our light! It works! We're turning dinosaurs into electricity. Yeah! Fist bump. Oh, that's so cool. Got our oil pressure, battery. Nice. All right, turn this off. One more. Good. I actually screwed up the, supposed to open that, but.
That was cool.
All right, it did it. It turned it on. Now I threw an amp meter on this and it does an inrush of 650 amps, at least as of right now, because the generator is actually fairly warm because I had it in the garage. If it was left out in the cold, it would draw more amps because everything would be harder to start. Thank you everybody so much for watching. If you'd like to purchase anything from Battery Hookup, please check out the links in the description below and use discount code David Poz. Thank you everybody. Please like, subscribe, comment, and share.
Why do you say that?
All right, this is the first time I'm gonna try this jump pack. Let's see if it works. Turn on our BMS.